Hello, good day viewers. Here is question number 10 of NECO 2024 Mathematics Examination Theory Questions, which is under quadratic equation, that is the graphical solution. Question number 10a, we are asked to copy and complete the table for the function x squared plus x minus 12. Already we are given some of the values. The limit is given from -4 down to 4, that is for the values of x, and we are given 4 other values of y, and we are asked to compute for the rest. Then the B part, we asked to use a scale of 2 centimeters to represent 1 unit on x-axis and 2 centimeters to represent 5 units on y-axis to construct the graph of this relationship, y equal to x squared plus x minus 12. Then the C part, using the same axis, draw a graph of y equal to 2x plus 1. Then the D part, from your graphs, determine the roots of the quadratic equation x squared minus x minus 13 equal to 0. And lastly, we asked to find the minimum value of y from the quadratic graph. All right, we are going to start with the first one where we asked to copy and complete the table. But I would like to suggest something here. Do not use this type of table because you have to show all workings. Instead, use this type. You see that? We are going to write x here and write y here to the bottom. And remember, the limit of x is already given from -4 down to 4, right? So we have -3, -2, -1, 0, 1, 2, 3. This is already given. Then you need to fill out these 3 terms. That is x squared, then x, then -12. You should know that -12 is constant, so we are going to fill it all across. All right, something like this. So what happened if x is -4? -4 squared will give us 16, right? Then x is already -4, so we have -4 here. So to find the value of y, all you have to do is to compute for these 3 terms. 16 minus 4 will give us 12, and 12 minus 12 will give us 0, right? Then you move to the second one when x is -3. -3 squared is 9. Already x is -3. Then you compute for these 3 terms to get the value of y. That is 9 minus 3 is 6. 6 minus 12 is -6. Then when x is -2, we have -2 squared, which is 4. This is -2. 4 minus 2 is 2, and 2 minus 12 is -10. Then when x is -1, -1 squared is 1. Then this is -1. 1 minus 1 is 0. 0 minus 12 is -12. Then when x is 0, 0 squared is 0. This is also 0. 0 plus 0 is 0. Minus 12 is -12. Then when x is 1, 1 squared is 1. This is 1. 1 plus 1 is 2. And 2 minus 12 is -10. So this is -10. When x is 2, 2 squared is 4. Then this is 2. 2 plus 4 is 6. And 6 minus 12 is -6. Move down here when x is 3, 3 squared is 9. This is 3. 9 plus 3 is 12, and 12 minus 12 is 0. Move down here when x is 4, 4 squared is 16. This is 4. Add these 2 together, you get 20. And 20 minus 12 is 8. So we have just completed the table and we're good to go. Then the B part, we ask to use a scale of 2 centimeters to represent 1 unit on x-axis. Already I have my graph here. On x-axis, every 2 centimeters should represent 1 unit. So you can see that 1 centimeter, 2 centimeter, we have 1 unit. 1, 2, we have 2. 1, 2, we have 3. 1, 2, we have 4. And if you move to the left, we have 1, 2, this is -1. 1, 2, this is -2. 1, 2, we have -3. 1, 2, this is -4. All right. But they said that we should use 2 centimeters to represent 5 units on what? On y-axis. 2 centimeters to represent 5 units. 1, 2, 5 units. 1, 2 plus another 5 making 10. 1, 2, that is 15. 1, 2, this is 20. You can leave it like this. Come down here. 1, 2, we have -5. 1, 2, we have -10. 1, 2, we have -15. So next, because they say we should construct this quadratic function, right? Already we have our table here. So what happened when x is -4, y is 0? So that is what we need to locate. -4, 0. This is -4. Where is y equal to 0? Exactly on the point. So that is on the line horizontally. Then next, when x is -3, y is -6. So -3, -6. This is -3, y is -6. Already this is -5, -6. We have 2 small points after, because every 2 small lines represent 1 unit if you count. Then we go back again. When x is -2, we have y to be -10. That is -2, -10. This is -2, y is -10. This is where we have -10. Let's continue. Then -1, -12. This is -1. Let us locate -12. You know that this is -10. So we need 4 small lines extra, right? So let me zoom it a little bit. 1, 2, 3, 4. Somewhere here. Then when x is 0, y is -12. When x is 0, y is -12. This is exactly where x is 0, so we need to locate -12. -12, the same point with the previous one, right here. So what happened when x is equal to 1? When x is +1, y is -10, right? So 1, -10. This is where we have 1, y is -10, this is -10. When x is 2, y is -6. When x is 2, y is -6. This is 2, y is -6. This is -5, so we need 2 small lines extra somewhere here. When x is 3, y is 0. When x is 3, y is 0. This is where x is 3, y is 0. That is on top of the line somewhere here. And lastly, when x is 4, y is 8. When x is 4, y is 8. So this is exactly where we have 8. All right. Next, we need to connect all of these points together in order to construct the graph of this function. So we have successfully constructed the graph of this function. Then next, using the same axis that is on the same graph, draw a graph of y equal to 2x plus 1. So that is our next target. So the C part, we asked to construct the graph of y equal to 2x plus 1. We have x, we have y here. All right. Let me choose point to the left-hand side, maybe -4. -4. So if x is -4, we have -4 times 2, that is -8, and -8 plus 1 will give us -7. So y will be -7. And don't forget, we have another important point, which is the y-intercept. That is exactly where the line crosses y-axis, and it is at what? X equal to 0. So if x is equal to 0, what happened? We have 2 times 0, which is 0, plus 1 is 1. So 1 is y-intercept, and you can clearly see that here. And next, I would like to take the last value here, which is 4. Very important as well. So 4 times 2 is 8. 8 plus 1 is 9. So I need to construct a graph of this. So when x is -4, y is -7. So let me use blue marker. We have -4 here. We need to locate -7. This is -5. For -7, we need 4 extra small lines. 1, 2, 3, 4. Then the second point is when x is 0, y is 1. This is where x is 0, so we need to locate 1. This is 1 somewhere here. Then the last point here is 4 and 9. We have 4 somewhere here, so where is 9? Y will be somewhere here. Remember, we have 8 very close to that point. So now let us connect the 3 points together. All right, so you can see that this is the graph of y equal to 2x plus 1. Remember that the previous one, which is the quadratic, is a graph of y equal to x squared plus x, then minus 12. So we're done with this question. Now let us move on to D part. Then the D part, we asked to find the roots of the quadratic equation x squared minus x minus 13 equal to 0 from the previous graphs. That is the 2 graphs we have constructed. All right, let me just copy this one. So the D part, we would like to find the roots of this quadratic equation without forming new table. We have to use the previous graphs. So how can we do that? We need to find which function that can be added to this function to make it equivalent to the previous function. The previous function, remember, for this graph is what? X squared plus x minus 12. So I would like to take this function x squared minus x minus 13 and think of what I can add to it. Let me choose a certain variable like a, so that it will be equal to the previous one, which is x squared plus x minus 12. So once I obtain the value of a, we are going to graph it, and notice the point of intersection between a and the previous quadratic graph. That is what we are going to do. So we can easily cancel x squared from both sides just by subtracting x squared on both sides, right? And again, we can take this 2 times to the other side, leaving only a since we are looking for a. So a will be equal to, as negative x crosses over, it becomes x. As this crosses over, it becomes positive as well. And already we have x minus 12. So you can see that x plus x will give us what? 2x. And 13 minus 12 will give us 1. So this is e. So we need to construct the graph of 2x plus 1. Then we notice the point of intersection between this graph and the previous quadratic graph. But if you observe, we have already constructed the graph of 2x plus 1 previously. Just remember it is right here, right? And it is said to be this linear graph. This is why the examiner said from the previous 2 graphs. So we need to find the points of intersection. So you can see that we have a point of intersection, and we have another point of intersection right here. So let me construct a dotted line, another dotted line here. So these 2 points are said to be the roots of that quadratic equation. And you can see that we have negative 3.1 something, and we have 4.1 something. So we can clearly say that the roots of x squared minus x minus 13 equal to 0 are negative 3.1 and 4.1 approximately. These are the roots. Then the last question here, we asked to determine the minimum value of y. That is the e part. And what is minimum? Minimum is nothing but just the turning point. So y is equal to, let us go to the graph and notice the point, the turning point. So probably you can see that this is the turning point, right? This is the turning point. That is the lowest value of y, which is at this point. So if you observe, since our graph is not that accurate, you can just pick the point. And this is probably at negative 12.5. So therefore, the minimum value of y is negative 12.5. Negative 12.5. And hence, we have just answered question number 10. In our next tutorial, we are going to answer question number 11. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.